Okay guys, so today in class we talked about how to write inequality statements, how to graph them on a number line. Tonight we're going to learn how to actually solve a one variable inequality that results in a solution that looks like the inequality statements we worked with today. Solving an inequality is the same, very similar in process as solving an equation. It's just your answer looks a little different. When you solve an equation, you get an answer like x equals 10. When you solve an inequality, you don't have an equals in there. You get something like x is less than 10 or x is greater than or equal to 10. So as we've already learned, the solutions to an inequality get graphed on a number line. When you solve an inequality, you use the exact same steps that you would use when you solve an equation. So taking a look at example number 1, and one thing I'll mention, a lot of times what kids do is by the time they get down to the bottom to their answer, they've suddenly forgotten that they were solving an inequality and they have an equals in their answer. So make sure you pay attention to the fact that this is an inequality we're solving, not an equation, and so our answer should relay that. Alright, so to solve this inequality, the first thing we would have to do is get the x to one side. So minus 3x from both sides. 5x take away 3x is 2x. Plus 2 is greater than, these cancel, you're left with 10 on this side. Isolating the variable on the left side, you would have to subtract 2 from both sides. You get 2x is greater than 8. And now dividing by 2 on both sides, you get a solution of x is greater than 8 divided by 2 is 4. Put it right on the answer blank. X is greater than 4. Now to graph this solution on a number line, like we did today in class, we'd put the 4 in the middle. I'm actually going to count by 2's on my number line because I write large and I may not be able to put a number on every hash mark, but if 4 is in the middle, that would be 5, 6, 7, 8, 3, 2, 1, 0. Since the solution contains only the values greater than 4, but not not equal to 4, you'd use an open circle on 4. And of course all the values greater than 4 would be to the right of it. And just for fun, let's practice writing our solution in set notation. Curly bracket, we're defining x such that x is greater than 4. In interval notation, it's a lot easier to write interval notation when you have the number line to look at. You always look at your graph from left to right. On the left side, our interval is starting at 4, but not including 4, so that would be a curved bracket. On the right side, we have an arrow, which indicates that the solution goes on and on and on to positive infinity. And like I said in class today, you can never actually get to positive infinity, so you never put a square bracket next to infinity or next to negative infinity. Looking at number 2, it looks like we already have the number negative 99 on the left side, so let's do minus 9x to get the variable on the right side of the inequality. These cancel, you're left with negative 99 is less than or equal to 18x minus 9x is 9x. To finish getting that variable by itself, you divide both sides by 9. Negative 99 divided by 9 is negative 11. Is less than or equal to. The 9's cancel, you're left with x. Now I typically tell kids to always start their inequality solution statements with the variable, not with the number. So I'm actually going to turn this around when I write it on the answer blank. If I read it backwards, it says x is greater than or equal to negative 11. So I just kind of took this and flipped it around. So negative 11 would go in the middle. I'm going to do sum above. It would be negative 10, negative 9. negative 8, negative 7, negative 12, negative 13, negative 14, negative 15. The x values that are appropriate for this inequality are not only the x values greater than negative 11, but also equal to. So that means we're going to color in the circle on negative 11. And the values greater than that would be to the right. In set notation, it would be the variable x, such that x is greater than or equal to negative 11. And in interval notation, remember, you got to start from the right side. We're starting the interval at negative 11 and we're including it. The square bracket indicates inclusion of the endpoint. And this arrow on the right indicates that the solutions go all the way to positive infinity. Since we can never get to positive infinity, we use a round curved bracket. Now there's this one rule that you need to remember, and it's hard to remember. The rule says if when you are solving an inequality, you divide by a negative number in the last step, you must reverse the direction of the inequality symbol. And no one's going to remind you of that. When you get to the last step, like we did here we divided by a positive 2. So we didn't need to reverse the inequality symbol. In the second example, we divided by a positive 9. So we didn't need to reverse the inequality symbol. By the way, it doesn't matter if you're dividing into a negative number. The rule stands for when you're dividing by a negative number. I think if I show you why this is the case, you might not forget to reverse the inequality symbol when you divide by a negative. Take a look at this inequality statement. 2 is less than 6, for example. Well, that's a true statement. 2 is less than 6. Let's say I were to divide both sides by a negative number, like negative 2. Well, 2 divided by negative 2 is negative 1, and 6 divided by negative 2 is negative 3. Would it make sense to keep the inequality symbol the same way as it was in the original statement? Well, it wouldn't, because negative 1 is not less than negative 3. Negative 1 is actually closer to the positive numbers than negative 3 is. So that's why when you divide by a negative number, you have to reverse the inequality symbol. Negative 1 is actually greater than negative 3. And by the way, the same is true when you multiply by a negative number. You also have to reverse the inequality symbol. For example, if I were to multiply this side by negative 2 and this side by negative 2, 2 times negative 2 is negative 4. 6 times negative 2 is negative 12. Would I be able to keep the inequality symbol in the direction it's facing now? Is negative 4 less than negative 12? It's actually not. Negative 4 is closer to the positives than negative 12 is. So also when you multiply by a negative number, you have to reverse the inequality symbol. And I'll be obnoxious when we're solving inequalities together in class, and when we do a couple of these examples on the notes. Whenever we divide, I'll ask you, did we just divide by a negative? And hopefully you'll just become very used to reversing that inequality sign when you do so. So let us now look at some examples where this might happen. On the back example 1, we're going to solve this just like in an equation. We've already got the 40 on the right side, so let's subtract 8x from both sides to get the variable on the left. Negative 2x minus 8x is negative 10x. Is greater than, these cancel, you're left with 40 over here. Now to get the x by itself, you'd have to divide by negative 10 on both sides. Did we just divide by a negative number? We did. We divided by negative 10. So these negative 10s cancel, you're left with x on this side. And because we divided by a negative number, we must reverse this inequality symbol. And 40 divided by negative 10 is negative 4. So we get x is greater than negative 4 for our answer to this one. So we're going to put negative 4 in the middle. Negative 3, negative 2, negative 1, 0. Negative 5, negative 6, negative 7, negative 8. This solution says that the x values that satisfy this inequality, that make it true, are all the x values that are just greater than negative 4. So that means we're going to put an open circle on negative 4 because we're not including it in the solution, and the values greater than that are to the right. In set notation, we would say x such that x is greater than negative 4. And in interval notation, remember, you always look at interval notation from the left to the right of your graph. On the left, our lowest part of our interval is negative 4, but we're not including it. So curved next to negative 4. On the right, we have an arrow that indicates that we're going to go on and on and on to positive infinity. But since you can never really get to positive infinity, you use a curved bracket there as well. Now for number 2, there's a fraction in there. You know, if you ever really just want to make your life easier and change the fraction there to a decimal, negative 1/2 is the same as negative 0.5. As long as it's not a repeating decimal, that's fine, you can do that. We're going to have to distribute. Negative 1/2 times x gives you negative 1/2 x. Negative 1/2 times negative 4 gives you positive 2, is less than or equal to 12. Remember, don't inadvertently change that less than or equal to into an equal sign. To get the x by itself, we would subtract 2 from both sides. We get negative 1/2 x is less than or equal to 12 minus 2, which is 10. Now dividing both sides by negative 1/2. Oh, did we just divide by a negative number? We did. So in our solution, our inequality symbol is going to switch and face the other way. Our negative 0.5's cancel. You're left with x on this side. And what is 10 divided by negative 0.5? Well, a positive divided by a negative is a negative. And 10 divided by 1/2 is not 5. 10 divided by 2 is 5. 10 divided by 1/2 is actually 20. There's 20 halves that fit inside of 10. So our solution is x is greater than or equal to negative 20. I'm going to put negative 20 in the middle, negative 19, negative 18, negative 17, negative 16, negative 21, negative 22, negative 23, negative 24. X can be greater than negative 20, but it can also be equal to. So an open or a closed circle, got to color it in to include that value of 20. And again, our arrow would go to the right because we want the values greater than or equal to negative 20. In set notation, x such that x is greater than or equal to negative 20. In interval notation, you would put a square bracket next to the negative 20 because we're including it in our answer. And the arrow indicates we go all the way to positive infinity. Can't put a square bracket next to infinity. You'll never get there. Let's just do a couple more examples. In this next one, you would have to distribute. You'd end up with 14 is less than or equal to negative 2 times 4x is negative 8x. Negative 2 times 5 is negative 10. We have the variable on the right side, so let's do plus 10 to both sides to isolate that variable. 14 plus 10 is 24, is less than or equal to negative 8x. To finish getting that x by itself, you would divide by negative 8. Oh, wait a minute. Did we just divide by a negative number? What do we have to do to this inequality symbol? We have to reverse it. These negative 8's cancel. You're left with x on this side. And 24 divided by negative 8 is negative 3. Again, I want you to turn that around. If you read it backwards, it says x is less than or equal to negative 3. So let's write the answer that way, starting with the variable. Negative 3 would go in the middle. Negative 2, negative 1, 0, 1. Going backwards, negative 3, negative 4, negative 5, negative 6, negative 7. Not only is the solution set containing numbers that are less than negative 3, but also equal to. So we're going to color that in. And the values of x that are less than negative 3 would be the ones on the left. In set notation, it would look like this: x such that x is less than or equal to negative 3. In interval notation, remember, you got to go from the left to the right. So in this case, on the left side is your arrow, and that arrow is going all the way to negative infinity. You can't have a square bracket next to positive infinity. You also cannot have a square bracket next to negative infinity. On the right side, the interval ends at negative 3, and negative 3 is included in the solution, so it would be a square bracket. One more example. Here we would bring down the 3x and distribute. 2 times x is positive 2x. 2 times 5 is positive 10. Greater than or equal to 15. Combining like terms, 3x's plus 2x's gives me 5x's. Plus 10 is greater than or equal to 15. Subtracting 10 from both sides, we will isolate that variable and get 5x is greater than or equal to 15 minus 10 is 5. Now dividing by 5 on both sides. Did we divide by a negative number? Well, in fact, no, we didn't. We divided by a positive number. So we don't have to worry about reversing the inequality symbol this time. It's going to remain x is greater than or equal to, and 5 divided by 5 is 1. Put the 1 in the middle. And again, you should label every hash mark. I'm just skipping every other because I write too large. That would be 0, negative 1, negative 2, negative 3. Since the solution contains all the x values that are not only greater to 1 but equal to, we'd color the dot in on 1. And then, of course, the values that are greater than 1 are the ones to the right of it. In set notation, our solution looks like this. It's the variable x such that x is greater than or equal to 1. In interval notation, again, from left to right, on the left side, the interval begins at 1, and you'd put a square bracket next to it because we're including it. On the right side, you have an arrow which indicates it goes on and on to positive infinity. You can never touch positive infinity, so a curved bracket on that side. So you'll get a lot more practice with this tomorrow, and I hope you have a wonderful evening.